Today's topic is going to be on Nexus 9000. So Nexus 9000 family, these are core layer switches. The specialty the speciality about these switches is that these are the only switches in the entire Nexus family that can work with two operating systems installed on them. Of course, one operating system at a time, but you can insert two operating systems, and this is only and only supported on Nexus 9000 devices. So like I was saying, speciality about Nexus 9000 device is that these are the only devices that can work with two operating systems. Of course, one operating system at a time. All right.
Okay, bro.
You can insert NXOS operating system on these devices, or you can also insert or install ACI operating system. All right. You can insert either of the operating systems when you have installed ACI operating system. The device behaves either as leaves or spines. So yesterday when we were just going through the different topics about what are going to be covered throughout this entire course, we did have a very brief discussion on what ACI is, and I mentioned to you that ACI only works on a two-tier architecture. Two-tier architecture is nothing but your collapsed core architecture, right? That is where your core layer as well as distribution layer switches, the functionality is combined into one. This particular switch can be called as the aggregation layer switch, or it can also be called as spine. And apart from that, of course, there is also the access layer switch, and this is called as leaf. So spine and leaf architecture is what ACI uses, right? So when you have installed ACI operating system on the 9000 devices, the device will either behave as the leaf or as the spine. On what basis is this decided? It actually depends on the ASIC that is inserted. All right. So ASIC stands for Application Specific Integrated Circuit. Please do make note of this. Every device or every line card, if in case it is modular, has its own ASIC. ASIC stands for Application Specific Integrated Circuit. This is a hardware chip that is always present on the switches or on the line cards, which gives some sort of intelligence. So, depending on the ASIC, the device will either behave as a leaf or a spine. We'll get into the details as we move on. So, Nexus 9000 devices are broadly classified into two series. There is the 9500 series and 9300 series. So we'll first finish off 9300 series, sorry, 9500 series, and then we'll move to 93. 9500 series of the Nexus 9000 family, these are all modular switches. So modular switches means that now every switch has always three planes, that is the control plane, data plane, and management plane, right? Control plane is what? This is the decision maker of that particular device. It's the brain of the device. All your routing protocols, exchange of routing updates, all of these are always considered a part of the control plane. This is what calculates the best path for you to reach from one node to the other, right? Control plane, like we've already mentioned, is always a part of the software. It's always a part of the CPU. Next is the data plane. Data plane is the actual movement of data depending on whatever decisions were made by the control plane. The last one is management plane. Management plane is nothing but how it is that you manage your device. right? So every networking device has these three planes: control plane, data plane, and management plane. Now, if these three planes are segregated in terms of different modules that you can insert on the chassis, then such devices are called as modular devices. Please do make note of this. If in case your control plane, data plane, and management planes are segregated in terms of modules that you can insert on the device, then they are called as modular devices. So 9500 devices, they are all modular. There are mainly three hardware models. One is 9504, 9508, and there is 9516. These are the three hardware models of the 9500 series: 9504, 9508, 9516. Now, the first two digits, we all know what it means. It is basically representing the series that the device belongs to. What about the last two digits? So there's 4, 8, and 16. We will discuss this in just 2 minutes. All right. What do these represent? 4, 8, and 16. We will discuss that in 2 minutes. Next. Now, because 9500 devices are all modular, of course, there are a couple of modules that you have to insert on this particular chassis, right? So the different modules, I'm just listing them out now. We will go to each of the modules and their functionalities. So the list of modules that are inserted on the 9500 devices are as follows. First one is supervisor module. This can be called as the supervisor engine, however you want to call it. Both of them are right. So soup module, soup engine, you can call them either ways.
Yeah,
Next
Madhuri.
is line card. So there's supervisor module, line card, a module called as fabric module, fan rack unit, power supply unit, and the last one is something called as a system controller. So these are the different modules that are inserted on a 9500 series. All right. So these are the things that we are going to be studying today. The 9500 devices and their respective modules. And if time permits, we can also move towards the 9300 devices. So 9500 devices, they have a very high port density, very high end switches. They are both layer 2 as well as layer 3 capable, extremely low latency. The power efficiency is excellent on these devices. These are the first modular chassis without a mid plane. Please make note of this. We shall discuss what a mid plane is, and their buffer sizes are extremely large. Like I mentioned, these are very high end switches, so obviously they will have a bigger buffer size, but these are the first modular chassis without a mid plane. Now, the question is, what is a
Hello,
mid plane? So let's take an example of a 7000 device, Nexus 7000. These are also modular switches. All right. Now, just assume this is the side view of your device. This is the front end of the device, and this is the rear end of the device. All right. All the other modular switches, they have something called as the mid plane. So like the name says, this plane goes right in between, right through the middle of the chassis. All right. Now, whenever it is that you're trying to insert modules, like for example, your line cards or your supervisor modules, the rear end of these modules get attached or clipped on to that particular mid plane. Similarly, when there are modules inserted from the rear end, like for example, fabric module, again the fabric modules get clipped on to this particular mid plane this way. All right. So basically, that mid plane is like a connectivity barrier for modules that are getting inserted from the front as well as from the rear end of the device. I hope everyone understood this. Mid plane, like the name says, is a plane that goes right through the middle of the device. Alright? Whenever you're inserting modules, be it from the front end of the device, like from here, or from the rear end of the device, the modules used to get clipped on or attached to that particular mid plane. So, this was like the connectivity barrier. All right, but the problem was there was no easy airflow between the front and the rear ends of the device. There was no easy airflow between the front and the rear ends of the device. So because of this, of course, there was a lot of heat that was getting generated within the chassis, within the device. So when they designed the 9500 modular devices, they completely removed the midplane. So now, whenever you're inserting modules from the front end or the rear end, they directly get attached to each other. There is no mid plane. Because there is no mid plane, there is easy airflow between the front and the rear ends of the device. Therefore, the cooling efficiency is much higher. All right, now there is no mid plane, they all directly just get attached. But before, there was a mid plane which was like the connection for modules that were getting inserted from the front and the rear ends of the device. All right, now moving ahead, these are the different These are the different components. So we've already gone through the list. The first component that we would like to talk about is the supervisor module. So please make note. Supervisor module is basically the brain of your device because this has both control plane as well as the management plane. So I told you, if your planes, the control plane, data plane and management plane, are separated in terms of different modules that you can insert on the chassis, then it is just called as a modular chassis, a modular switch, right? So here you have the supervisor module, and this consists of functionalities with respect to both the control plane as well as the management plane. So all your management ports, your console port, USB ports, everything is present on the supervisor module. It's the brain of the device. All right, so because this is such an important module, every single modular chassis, I'm talking about the 9500 devices as of now, so every single 9500 modular chassis will always have two redundant slots into which you can insert the supervisor modules. Every single modular chassis will always have two redundant slots into which you can insert the supervisor module. Now, of course, Cisco says that the best practice is to insert two supervisor modules into both of these slots. But that is just the best practice. All right. Can I have just
Master backup
supervisor
scenario.
module inserted? All right. So there are two dedicated slots into which you can insert the supervisor modules. Now, best practice is for you to insert two supervisor modules, but will my device work even when I have one supervisor module inserted? Yes. You can just insert one supervisor module, your device will work without any issues. All right. Best practice is to have two. Now, when you have two supervisor modules inserted, they always behave in an active standby role. You can never make the two supervisor modules on the same chassis in an active role. That is impossible. Okay, so one supervisor module will always be active, the other one is always going to be in standby. Is there any election process for this? Any priority or something? No. Whichever supervisor module you insert first, that supervisor module becomes active, and of course, the other one becomes standby. All right. So there is no election process for who has to be active and who has to be standby. Whichever one you insert first, that is active, the other one is standby. Always, for the insertion of supervisor modules, there are dedicated slots. You cannot insert the supervisor module anywhere and everywhere you please. Okay, there are always dedicated slots for you to insert the supervisor module. Yes? So did everyone understand this? I hope. Supervisor module is the brain of the device. This consists of both control plane as well as management plane. There are always two dedicated slots for you to insert the supervisor module. Best practice is definitely to insert two supervisor modules for redundancy. They always behave in an active standby role. Active goes down, immediately the standby comes up. There is no way that you can make them active at the same point of time. All right, if you want to manually change their roles, you can do so by logging into the CLI of your device and giving the command to switch over. Otherwise, the only way is to physically remove a supervisor module, and the active supervisor module or the inserted supervisor module will take over the role change. Now, one more thing is, what happens if I have inserted only one supervisor module on my device and this one supervisor module goes down? The scenario is, I have inserted only one supervisor module on my device and this one goes down. So what happens? I only lose access to control plane and management plane. That does not mean my device has completely gone down. All right. So if you have one supervisor module and that supervisor module goes down, you will completely, of course, lose access to control plane as well as management plane. So if there are any existing flows means where the device knows who is the source and who is the destination, there will be no impact. Okay, so if there are any existing flows, existing connections, there will be no impact. But if in case there are any new connections where there's an update that has to be made to the MAC address table or something like that, those frames or those packets are immediately dropped. But again, there is a thing over here as well. Like I mentioned, for existing flows, there is no impact, but that again is always temporary. Okay, so if there are any failures, please make sure that they are fixed at the earliest. If in case this one supervisor module goes down, I mentioned to you that there will be no impact on existing flows where you know who your source is and who the destination is. But that will happen only temporarily. Even after 6 minutes, in case you have no working supervisor module or active supervisor module on the device will keep reloading. Okay, so at the end of every 6 minutes, the device will keep reloading. So please be careful and please fix whatever failures it is that you're facing. If there are any failures, yes, momentarily there will be no such impact, like a very big impact, but that is just temporary. So you need to make sure that it is fixed at the earliest. And one more point is, supervisor modules that are available for the 9500 devices are all half width modules. So throughout the course, if I ever use the term as half width module, that means that the module is half the width of the chassis. All right. If any module is said to be a full width module, that means that the width of that module is the full width of the chassis or of the device. Supervisor modules for 9500 devices are all half width. So you will find two dedicated slots like these where you can insert the supervisor engines. All right. Now, this is how your supervisor engine looks like. This is how the supervisor module looks like. So you can see here, you have an external PPS, pulse per second clock input. You have the management port, the console port, and you have USB ports. All right. Now, there are different types. There are different variants of the supervisor modules available for 9500 devices. They are as follows. There's Soup A, Soup B, Soup A plus, Soup B plus. So A plus and B plus, these are just the enhanced versions of Soup A and Soup B. Whenever you're inserting your supervisor modules, please be careful to make sure that the same type of supervisor module is inserted on your device. You cannot have a combination of the different types of supervisor modules inserted on the same device. Okay, what I'm trying to say is over here, if on this is slot number that I'm writing, it's not the type, it's the slot number, soup 1 and soup 2. So here let us just say I have inserted soup A. Please make sure that on the redundant slot present on the same chassis, you're inserting soup A over here as well. The type must be the same. You cannot have a combination of A and let's say A plus present on the same chassis. It is not supported.
I have a question regarding
Supervisor module. The next one is something called as the system controller. So please make note, this particular module, which is the system controller, is only present on the 9500 modular switches. Only on 9500 modular switches. System controller is not present on any other modular switch. What does this do? The system controller takes some load off from the supervisor module and monitors for any failures with respect to the power supply units or even the fan rack units. All right. It also handles the communication between the different supervisor modules that you have on your chassis. All right. So all of these, of course, were traditionally done by the supervisor module, like on the 7K and all of that. Everything was handled by the supervisor module alone. But because there was a lot of load on the supervisor module, when they designed the 9500 devices, they made sure that they were putting in another module, which is called as a system controller, which would take some load of the supervisor module and would monitor for any failures with respect to the power supply, the fan rack, as well as handling supervisor module to supervisor module communication. Next is with respect to the power supply. So power supplies that are available for 9500 devices are 3 kilowatt AC power supplies. Now whenever you're using the power supplies, there are two modes that you can configure them in. This again is as per your choice. Okay, so you have two modes. There's something called as N plus 1 and there's something called as grid. So what is N plus 1? Now let us just say there are four power supplies. For example, I have four power supply units on my device. So what is N plus 1? N plus 1 is where any three power supplies are made active. They are continuously supplying power, they are active. The other one is in the standby mode. This is what is N plus 1. All right. If suppose in case I have four power supply units, any three power units or any three power unit supplies are made active. The other one is kept in standby. If any of these active power supplies goes down, the standby becomes active. All right. This is what is n plus 1. Apart from this, there's something called as grid. Now, whenever you have grid, it is mandatory for you to have even number of power supply units. Like I've mentioned over here, 4 power supply units, right? It is the best practice or mandatory rather for grid mode key you should have even number of power supply units. So I'm taking the same example over here. Assume I have 4 power supply units on my device. The first half of the power supply units, the first half of your slot for the power supply units is considered as grid A, and the second half of your power supply unit is considered as grid B. Both of these grids, when using in grid mode, both of these grids must be connected to completely different power sources. Okay, so grid A are these 2 power supplies, grid B are these 2 power supplies, power supply units. They both are connected to completely different power sources, but both of them are active, both of them are continuously supplying power to the chassis. All right, now it is, if in case one of your power supply goes down, of course both of these power supply units will stop supplying power to your device, but you still have the other grid working, and it is highly unlikely that both the power supplies are down. Okay, only in grid mode you can have your power supply units connected to completely different power sources, and they have to be mandatorily connected to completely different power sources. The grids are automatically formed whenever you choose this mode. Both the grids will always be active. There is no active standby in this particular situation. Both of them are active. If in case your one power source goes down, then of course you still have the other one that is continuously supplying power to your entire device. It is highly unlikely that both the power sources go down. All right, so grid, whether it's on the Nexus switches or whether it's on any other platform, is always considered as the mode that provides the highest level of redundancy with respect to power. The next module is line card. So what is line card? Now, line card is a module that has multiple interfaces, ports present on it. Okay. Now, again, there are different types of line cards. You can go through the specification sheet and buy it as per your choice. There are RJ45 ports, there are SFP ports. It depends on whatever it is that you're trying to deploy, that you can buy the appropriate line card. So these are modules that have these physical interfaces present on them. So obviously it is through the physical interfaces that the actual movement of data takes place. Right? So your line card always represents the data plane functionality of your device. Okay, so control plane and management plane was taken care of by supervisor module. But where is the data plane? It's always represented as a part of your line card. All right, there are different types. You can go through the specification sheet and buy it according to your choice. The number of ports, they keep differing from the, with respect to the different variants. The bandwidth or the speed of each of the ports will keep differing. The type of port, like I mentioned, RJ45 ports, SFP ports are available, so you can go through that as per your requirements and buy it. Now, with respect to the line card, there are different variants of line card that are available for 9500 devices. Okay, devices we've already seen, there's 9504, 08, and 16. So the different series of your line cards are the 9500 series. This is the line card series I'm talking about. 9600 line card series, 9700 line card series. All right. So there are mainly three series of line cards that are available for 9500 modular devices. There is 9500 line card, 9600 line card, and 9700 line card. Now, I previously mentioned to you that suppose you are installing ACI operating system on the device. I mentioned to you that the device is either going to work as a leaf or it is going to work as a spine. It depends on the ASIC, was what I mentioned to you, right? ASIC is not something that you can just plug in. It's a hardware specification. It's the way the device was manufactured. All right. But here we are looking at modular devices, which is nothing but the 9500 device. These are modular devices, right? So where is the ASIC present? The ASIC is present on the line card. If your device was fixed, like in the case of 9300 devices, all of these devices are fixed. There is no module that you have to insert. All right. In such cases, the ASIC is present on the device itself. But here, because you're dealing with modular devices, the ASICs are present on the line card. All right. So, whether your device is going to behave as a leaf or spine, like I mentioned, depends on the ASIC. Here you are dealing with ASIC present on the line card. So for the 9500 devices, you can have a line cards behaving as leaves or spines. I'll explain it with an example. Just make note of it for now. 9500 line cards do support whenever it is that the device has been installed with NX OS, that is the Nexus OS software. If in case you have installed ACI operating system, then also this particular line card can be used. Okay, this line card will work when you have installed Nexus operating system on the device. This line card will also work when you have installed ACI operating system on the device. Now you are dealing with ACI. When in ACI operating system, does this line card behave as a leaf or as a spine? This particular line card behaves as a leaf. Why? Because, like I mentioned, the ASIC is on the line card. The ASIC is called as ALE. ALE stands for Application Leaf Engine. All right. So instead of the whole device behaving as a leaf or spine for ACI, because these are modular switches, the advantage is I can have my line cards behaving as leaves or spines all on the same device, all on the same chassis. All right. So these line cards, when deployed with ACI operating system, will behave or give the functionality of leaves because they have the ALE ASIC already present on them. 9600 line cards only work when you have installed Nexus operating system on the device. 9700 line card only work when you have ACI operating system present on that particular device. And when deployed with ACI operating system, these line cards give you the functionality of spines. All right. Now I'll give you a simple example. Can you have a combination of these different line cards all inserted on the same device? Yes. Let's say I have a device over here. I have 9500 line card, I have a 9600 line card, and I have a 9700 line card installed on this particular device, inserted on this particular device. And let's say I have installed the Nexus operating system on the chassis, on the device. All right. Because I have installed Nexus operating system, like you can see here, 9500 line card supports Nexus operating system, so I can use the ports on these devices for any of my connections. 9600 line cards also support Nexus operating system, so I can again use this particular line card as well for any of my configurations or connections. 9700 line card does not support Nexus operating system, it only supports ACI, right? So the ports present on this particular line card will not be available to me. When you check for show interface brief, or when you give the command as show module, right, 9700 line card will show as invalid because 9700 line cards do not support Nexus operating system, which is what you have installed on the device in this particular example. I hope everyone understood this. Now, what if I have another scenario? Again, I'm going to draw the same set of diagram over here. I have a 9500 line card, I have a 9600 line card, and a 9700 line card. And on this particular device, I have installed ACI operating system. Then what? 9500 line card does support ACI operating system, and when it does, it is behaving as a leaf because it has ALE. So this particular line card behaves as one leaf. All right. 9600 line card does not support ACI operating system. So when you give the command as show module, this is again going to show me as invalid. I cannot use these ports present on this particular line card when I have ACI operating system installed on it. When I have a 9700 line card, 9700 line card does work with ACI operating system, and when it does, it is giving me spine functionality because it has ASE, application spine engine, right? So this particular line card now works as one spine, right? So you have a leaf, you have a spine. What I can do is I can just have a physical connection between port, one port connected over here, so this is as good as a leaf connecting towards the spine. All right. What if I want to have another leaf? If there are more slots for me to insert the line card, I can go ahead and insert another 9500 line card, which is anyways going to give me the leaf functionality. So this is as good as having another leaf on the same device. You see that? So instead of me spending on dedicated devices behaving as leaves and spines, what I can do, or the advantage that I have here because I'm dealing with modular devices, is that the line cards itself behaves as leaves and spines, all inserted and managed from within the same device. All right. So I mentioned to you that you have three hardware devices. You have 9504, there is 08, and there is 16. Right. So 95, we all know what the meaning is. It's the series that the device belongs to. But 4, 8, and 16, what do these represent? These represent the total number of slots into which you can only insert line cards. Now, those of you who are aware of Nexus 7000, I know it's a little different on Nexus 7000. It's a little different over here. All right. How many ever, or whatever is your digit, 4, 8, or 16, That represents the total number of slots into which you can only insert line cards. So, for example, 9504, four slots into which I can only insert line card. Apart from these four slots, I will have two extra slots into which I will be inserting the supervisor module. 9508, eight slots reserved for the insertion of my line card, plus two extra slots into which I can insert my supervisor module. 9516, 16 slots reserved for the insertion of my supervisor module, plus two extra slots into which I can insert my supervisor module. Now, the last module for the day um, is nothing but the fan tray. All right, so fan tray is something like this. So if you can make it out in this particular picture, you can see here that there is one fan tray at the rear end of the device, and there are a number of fans in each of these fan trays. All right, so every single device, whether it is 9504, 9508, or even 9516, all these three devices have three fan trays each, but the number of fans in each of the fan tray will of course differ device to device depending on the size. Bigger the device, you need more number of power supplies, you need more number of fans as well. But each of these devices have a total of 3 fan trays. The number of fans in each fan tray will definitely be different for each device. So you can see here, this fan tray is inserted only from the rear end of the device. And I'm not sure if you can make it out, but you can see these vertical modules over here, right? There are vertical modules that you can see. These vertical modules are the fabric modules, which we will be discussing in tomorrow's class. All right. So you first insert the fabric modules from the rear end of the chassis. So this is the rear end. Fabric modules are vertical. So you insert your fabric modules on this particular device. And on top of that, to cover it up, you insert the fan tray. So each device will have 3 fan trays. The number of fans will of course keep differing from device to device. If in case any of your fabric module goes down, so let's say this fabric module over here in the corner, this has gone down, right? The only way for you to service that particular fabric module is to remove this particular fan tray, take the fabric module off. That is the only way that you can take the fabric module off. You cannot remove the fabric module from the front end of the chassis. It's only removable from the rear end. All right, so you always insert your fabric module first, and then on top of that you insert the fan trays. You want to remove a fabric module, you need to remove the fan tray and then get it serviced. Now, whenever you have removed one fan tray, so in this particular example, I have removed this one fan tray. So what happens is the fans in the other fan trays, right? These fans in the other fan trays will increase their speed to compensate for the loss of this particular fan tray. I hope all of you understood. In this example, I have removed one fan tray. The remaining fans in the other fan trays will increase their speed in order to compensate for that loss. Okay? What happens if I remove 2 fan trays? First thing is, removing 2 fan trays at the same point of time is not supported. If in case you do that, your device is going to reload every 3 minutes. And eventually, once the heat has reached its maximum temperature, all the components will shut down. Okay, removing two fan trays at a time from one device is not supported. Your device will start reloading every 3 minutes. So, whenever it is that you want to actually remove multiple fan trays, please do not remove them at the same point of time. Remove one, get it serviced, fix it back, and then remove the other fan tray. Please do not remove two or more fan trays at the same point of time. Something that I have not mentioned on the slide. So please do make note of that. To service a fabric module, the fan tray must be removed first. If one fan tray is removed, the other two fan trays will speed up to compensate for the loss of cooling power. The temperature sensors in the chassis will shut down once the components have reached their maximum temperature. All right, so of course there are temperature sensors as well, and if in case you have removed both of these fan trays, all the components will eventually shut down, automatically shut down. So in order to avoid that, in order to avoid this continuous reload after every 3 minutes, please do not remove multiple fan trays at the same point of time. Remove one, get it serviced, fix it back, remove the other one later.